Seat size, change it to 500. It's generally double the size of the specimen, and hit continue. Leave this all the default. First select this elliptical tool. Select the center by entering the coordinate 0, 0, or just simply enter 0 and press enter. And the x coordinate I already calculated, 75.2, 0. So that's the x coordinate, and along the y coordinate you can define 0, 37.8. so that's the outer steel tube. And then inner one is again define 0 at the center, and x coordinate 7.02. Press enter, and along the y 0, 37.8, and press enter. Press the middle button. I think I made a mistake here. It should be press Ctrl Z. Again press elliptical. 71.0. Center is 0, and then along the x-axis 71.0, 2, 0. Press enter, and along the y-axis 0, 33.62, and press enter. That looks correct. Press the middle button again, press done. Height of the column is 300, and that's the part. To the partition, because we like to have a two layer of the mesh along the thickness of the steel tube, so choose this 3-point. I think choose this 3-point option. Select the 3 points which are in the same line. I have selected this 3-point and create the partition. Once you create the partition, select the surface and select the master surface. Just give the name master surface. Press continue and select this inside surface. Hold the shift key and then select the second surface, and then done. Second, click on the mesh, local shading, and select this one edge and shift key down and select the second edge. And once it's done, press done and select by number and 2 mesh along this thickness. So press OK. Once it's done, global shading 5 millimeters size of the mesh, so that's 5 millimeters, and press mesh and select the mesh. Once you've done this mesh, just go to the property module, select the material manager button, give the name steel, mechanical, elastic. I already created the file which has a property. This is the Young modulus and Poisson's ratio. Young modulus is 217,500 and the Poisson's ratio 0.3. and then define the plastic, and I have this property for the plastic one. Just paste this plastic one and press OK. Once it's done, then we can create the section. Steel tube, solid homogeneous, continuous. Select the material steel just we created. Once it's created, assign the section, uncheck these sets, select the whole part, and then select the steel sections, and done. The green color means it has a section property. Once it's completed the assigning of the sections, go to the assembly module, select this part instance, steel tube, and hit OK. Then create the reference point. Reference point 1 at here, so it is 0, 0. Another one is along the z-axis 300, so 0, 0, 300, and press it. So there are two reference point created. Go to the step module, create the buckle step for the defining to create the buckle of the steel tube portion. create the buckle step, enter 1 and 2. Once you created this one, go to the interaction modules, select this constraint manager, create the constraint, rigid body constraint, continuous, and select tie, and shift key down. If you just fit to the window, you can just round this one, and you can select this surface. For the try shift key down to select the multiple surfaces and hit done. And then reference point for this surface, control point is for this surface is the middle one, reference point 1, and hit OK. Same procedure for the top surface. Select the tie nodes, select the surface, shift key down to select the multiple surfaces, hit done, and then select the reference point, control point for the top surface, and hit OK. After creating the constraint, select the load module, apply the loading at the top surface, which is point load concentric. Select this reference point, hit done. Is along the z axis and is in negative z. The arrow indicate the direction of the loading. Similarly, boundaries we're gonna create at the initial, so just select the initial boundary for the initial step, select the displacement rotations, and then select the reference point 1. Done. So bottom end is fixed, so all the boundaries are fixed. Once it's created the load, you can check the mesh that we already created, and then go to the job module. Before creating the job, you may like to just edit the keyword, and go at the very end before the end step. Select, put the cursor, enter star node file u. That's create the displacement file for the each nodes. Now create the job 1, module 1, and just leave all this default. I'm not running this one because I will give you the file which has the results on this one. So just submit the button and it will run the analysis. Once you run the analysis, then you copy this model and give the name model 2. Now expand the model 2, create the concrete part. Now concrete, leave all default, select the elliptical drawing tool and center 0, 0, x axis point is 71.02, press enter, and along the y axis 0, 33.62, and press the middle button to out the elliptical tool, press done, and enter 300 for the height of the column. Once the concrete part created, select the surface, give the name slave surface, continuous, select this portion, and done. Second property module, create the material property for concrete, give the name concrete. First give the definition for the elastic property. Go to the tab for the concrete one, and I already have the elastic property for the concrete. For the plasticity, go to the Drucker pressure plasticity. 3 constant parameters are given in the Excel sheet. Use those parameters, and then also define the hardening, which are also already calculated in the Excel sheet. Now just copy and paste up those datas. So done, press yes, and the concrete material is created. Now create the section, which is concrete. Material is concrete, and then assign the section which is here. Select the whole part and press done. Select the section concrete. It turns green, means that it has a material property, the section property. Now meshing, these times we like to use the coarse mesh, so 10 millimeters of the global size applied. Hit OK and mesh the concrete part. Then go to the assembly module. Just select the concrete, so that has a concrete assembly. Before going to the next step, please expand this assembly tree assembly module and select the set number 1 is the first reference point. Set number 2 is the bottom surfaces including steel and concrete. Press the shift key to select these multiple surfaces and hit done. Similarly, for the top surface, set number 3 is the top reference point number 2, and set number 4 is the top surfaces including concrete and steel. Shift key down, select the concrete then steel and press done. So there are 4 steps we just created. Now go to the step module. Delete these buckle steps that we created in the previous model, and still create the new steps with the static general, and non-linear geometry is on, and leave all others default. Once you created the steps, now we need to select the outputs. So we like to record the reaction forces at the set number 1 at the reference point, and that's along the z-axis. So that reaction force along the z-axis, so 3 represents z, and press OK and create another output for the top, where we like to record the displacement, set number 3 reference point 2, and we like to displacement along the z directions, so u3. 2 output is created. Now interaction, first one, surface to surface interaction manager, create. Just select the initial one, surface to surface interaction. Surfaces we already created. Now it's asking the master surface first, so select the master surface. It's asking the slave surface. Now select the slave surface. Once it's created, it's asking the interaction property, so it's the contact property, continuous, tangential behavior, penalty, friction coefficient should be less than 0.6, between less than 0.6, so we selected 0.3, and the normal behavior hard contact, and press continuous. The interaction property is here, and hit OK. So the interaction property is defined for the steel and concrete surface. We like to have a constraint. We need to change this constraint because it has from the previous model. So it asking the surface first, so set number 2, and then the reference point is the set number 1, right, and press OK. Similarly edit, see here is just select the steel tube, but we like to have the concrete as well. So set number 3 has this geometry, and set number, sorry, I have wrong selection. Set number 4 I think is the surface. Set number 4 is a surface. Now it's highlighting, and the set number 3 is the control point, which is set number 3, 4, and continuous. So now it has all the rigid body constraint. Now the loading, we don't have any loading, but we like to have the loading in terms of the boundary condition. So the first one is the fixed boundary condition at the bottom, which has all the displacement, rotation are constrained. Second boundary condition is the displacement. So just select the step number 1, displacement, rotations, and the top reference point is set number 3, So we like to have all these constraint fixed, but in the z directions we like to apply some displacement, let's say 30 millimeters, and hit OK. Mesh, it has mesh we just created in the part module, and then we can go to the job. Now before creating the job, we like to apply the imperfection. So edit keywords, just right click on it to create the edit keywords dialog box. Disregard all edits, it has a property from the previous model one, so just disregard that. Scroll down, go to the step, enter, use the keyword imperfection. File name that need to read is job number 1. That's file number is from the previous model. I can show you that. So that's job number 1 that we have recorded, and then it should be step 1, and the imperfection is 0.03 in the 1. So hit OK. Now create the second job. When you create the second job, please make sure you select the job model 2, job 2, continuous parallelizations, multiple processors. So it if you press Ctrl Alt or Delete, you can find out how many cores you have. I have 1, 2, 3 and 4, so you can select 4 cores, right? So that make the process faster. Once you have job 2 created, you just select the submit button. I'm not going to run the model here, but I already run the models in the behind to save the time. So your model look like once you created this one, your models look like this one. Let me delete this first. Okay, so if you want to have the results output, hit on the XY data ODB display output, and continuous, select these two that we just generated and just leave as it is. Now first one is your load, and it's in the negative, means it's in the negative z direction. So we're gonna convert this one into positive. Control V, and just because this is in the Newton, so we convert into kilonewton. So load divide by 1000, and that's Control C, and we're gonna have this number. So that is your load in kilonewton. Now another one is the displacement that we like to have. So that displacement is extracted in this these sections, and that has a displacement, and the displacement we like to convert into displacement, so that would be divided by the original length. So that is change in length over original length convert into strain. So this is the strain, load versus strain curves. So that is strain, no unit for the strain. And then you can have this graph for the load strain curve, strain versus load curves. So this is the tutorial for the elliptical